Good morning, everyone. I'm the president of the Nigerian Society of Engineers, Engineer Papa Ghana Mohammed, past presidents of NSC and APWEN here present, our presenter, Vijay Natarajan, and all other participants, I welcome you. Engineer Shegun, I'd like to share my screen if you don't mind.
Hello.
Okay.
Hi, this is Vijay.
Yes.
Hi. So, yeah. So, shall we start or?
Yeah, no, just a minute, Vijay.
Okay.
We'll call you when it's time for you to start.
Okay, great.
Yeah. This morning we received the shocking news of the passing of the immediate past group managing director of the NNPC, that's the Nigerian National Petroleum Corporation, Engineer Dr. Maikanti Baru. He was a very, very supportive engineer to APWEN especially. With the support of NNPC under the leadership of Engineer Maikanti, APWEN constructed 7 ultra-modern science and technology laboratories, complete with motorized boreholes in 7 primary schools, distributed around the 6 geopolitical zones of Nigeria. 2 of those laboratories have been completed in Misau and Benin, and 5 others are yet to be completed. So for this, such a great man, we cannot just allow this to pass. I would like us to observe a minute's silence in honor of Engineer Dr. Maikanti Baru. May the gentle soul of Engineer Maikanti Baru rest in perfect peace. Amen. I'd like to invite Aisha Saad to please present the profile of our presenter today. Aisha.
Good morning, everyone. My name is Aisha Saad, speaking from Kano State, Nigeria. Vijay Natarajan is co-founder and COO of Qenergy, UK. A qualified engineer and sales and marketing professional, he has over 10 years experience in marketing and business development, strategy and product delivery management. He has worked on UK and European smart city and IoT solutions projects worth over £10 million in the last 4 years, utilizing agile technologies. As COO of Qbots, Vijay is currently leading the development of key commercial partnerships in the private and public sector, delivering digital energy projects within UK in energy management, demand-side response, behind-the-meter, BTM, battery projects, solar car pots, and smart EV charging with vehicle-to-grid, V2G. He also works with technology manufacturers, energy suppliers, aggregators, DSOs, city council, and installation teams. Vijay holds a bachelor's in mechanical engineering from India and a master's from Manchester Business School, University of Manchester, UK. Vijay, you have the floor.
Okay. Thank you very much. Thanks for everyone, and thanks for this wonderful opportunity to give me this opportunity to present. Hope you can hear me clearly. I will share my screen. And can you see my screen now?
Yes, we can see you.
Yeah, I think we can. Yeah.
All right, that's great. Yes, just to start by giving an intro to who we are. As you explained, so I'm Vijay, based in UK, and I'm a CEO and founder of Qenergy. We started Qenergy in 2018 March, and myself and Dr. Lee, and we have a team of 12 people at the moment based in Manchester and London. So our vision as Qenergy is to how can we accelerate, the adoption of renewable energy by making use of smart energy technologies, which are emerging technologies, and how we can make use of them to make it cheaper, and how can we make the adoption of renewable energy faster. So that's the whole reason we founded this business. And currently we are mainly focusing on the UK market. We are doing certain projects in Canada and China, and recently also doing a project in Nigeria. But in terms of the UK, the way our core proposition, core product is about creating localized energy markets that kind of incentivize people to participate into take an active role in the energy markets, to sell energy, buy energy, and make use of latest energy efficiency technologies. So one of them is we were some of the key projects that I would like to mention is last year we did this project in London South Bank area, which is, as you know, if you know London, so you have the the big wheel and all the important historic places. So that area is called London South Bank. So we worked with a community group there called London South Bank Employers Group. So we kind of modeled the region. There was a university, there is a hospital, there is different businesses, but looking at how we can have a local energy system, how we can have local generation, storage, and how we can optimize within that. So we did a lot of modeling and design work as part of a government project. We are also currently doing a 2.8 million project in Warrington, which is in the north of UK, along with Warrington City Council and energy companies. We are also consulting currently on a project in Bolton, which is nearby Manchester, on a new development. On a new development project, they have certain objectives in terms of how to reach net zero carbon emissions. So we are helping them to achieve those objectives, and what systems need to be in place so that they can become net zero once they develop this new regeneration development, which includes office buildings, residential, and retail developments. So the last one I want to mention is the UK-Nigeria project that we are doing. This project we've been awarded from the Department of International Development, and we are working with a partner in Nigeria based in Abuja, and we're also working with Manchester Metropolitan University. Basically, we are taking the same technology that we're developing in the UK and taking it to Nigeria and deploying it. Obviously, we need to be making a lot of changes, making it suitable for the Nigerian market. And we are trialing it in Kuje near Abuja, so connecting a school with a community around the school. So this is a team behind. So we have a variety of people from different backgrounds. As you can imagine, the new kind of energy industry, or the new kind of types of energy services industry, needs both software technology professionals. At the same time, we need experts from the energy industry. So we need a combination of skill sets to achieve this. So in terms of traction, already mentioned, our system is scaling. At the moment, we are, by end of this year, we would have 100 sites connected to our platform to do this kind of trading and optimization among them, and then trade with the energy markets. And we have won several awards from the UK government, from the Department of Energy, and also international development. We're working in partnership with different energy suppliers, Bright Energy being one of them, who's a strategic partner, and then some of the distribution system companies in the UK. We also have a lot of partnerships with battery and solar manufacturers, one of them including SunGrow, BYD, Tesla, and other ones. And in terms of some of our major clients, one of them is the Manchester Science Partnerships, which is like a science park in Manchester, and the property company that manages them. And we are also working with closely with academic partners, research partners, Manchester Metropolitan University being one of them. And thanks here, I want to mention to Bami Delhi, who introduced me to this program. This slide, I just want to talk more in general about the energy challenges that are facing the UK market and also the worldwide markets. The key thing to note is the energy trilemma, as they call it. So you have your sustainability, you have security and cost. What does it mean is, any government or any organization as participating in the energy system, they are faced with three big goals. One is, how can we make it sustainable? How can we make it renewable? As you know, we have the targets to become 80% less carbon emissions compared to 1990 levels by 2050. That is for every country in the world from the Paris Climate Change Agreement. And then you have security, which is the energy supply has to be there. There cannot be any power outages. And I'll talk about what are the challenges for that. And then the cost. So the cost of energy has to be kept low. So at the moment, this is again talking about the UK scenario. The coal power stations are going to stop by 2023. The solar capacity is increasing. Wind generation capacity is increasing. And we are getting to renewables of 34% renewable this year. But with this poses a lot of challenges, because when you go from traditional power generation sources to solar and wind, which means that there is more intermittency. That means there is more variability. When there is more sun, there is going to be more energy. Sometimes there's going to be less energy. Same with the wind. So which means it makes it difficult to manage the energy system. And then the next is the electric vehicles growth. So again, it is growing from 100,000 it was in 2017 to it's going to get to 1 million this year in the UK, which means it poses significant challenges, because electric vehicles need charging points. These charging points can be high capacity ones, and they will need a lot of power to charge these vehicles. So again, when you accumulate like hundreds of vehicles, it poses significant constraints and challenges on the electricity distribution network. And there are also local challenges as well, because the car, as you know, the electric cars can charge up in one place and then they can move to another place in the middle of the day and they can charge in some other place. And then in the evening, they can come home and then you might be charging near your house. So there's like, there's a lot of local challenges as well. And then electrification of heat, obviously this is more specific to UK and some of the colder countries where you have heat sources which are more gas-based, which is very carbon intensive. But if you want to be carbon neutral, then we need to move to electric heating. But then electric heating will add another 40 gigawatts to the peak demand in the wintertime, which means it's going to be huge increase in the need. So all this means that yes, we need to achieve sustainability. So the national grid of the UK have forecasted that if they become completely renewable, approach it in the current approach, which is having massive wind farms, massive solar farms across the country, or offshore, onshore wind farms, nuclear, and all the these kind of energy sources, and still do the whole management centrally. If they continue with that trend, more people, actually it will have more, the cost of energy will increase. Already in the UK, the green energy, the complete green energy, if you want to switch, the cost is more than buying a normal energy. And this scenario exists across the world as well. This means that the cost people pay at the end of the day will go up, which the government or any government and any system, political system, would not want, because the cost needs to be low so that it can be accessible to more people. And then the security, again, while you do all this, because of the variations from renewables and all the increase in demand, there can be blackouts possible. Even in the UK, where there is no blackouts, but recently there was a outage in certain parts because of the similar kind of reasons. So how to balance this is a very difficult task. And one of the solutions is decentralization, which means you're going to generate solar locally, you're going to have battery storage, solar, all of the generation and management as well, collection of data and management of the systems locally. And management of the usage as well, locally done, which can solve a lot of these problems, and also provide a lot of opportunities to local economy, to the local community, for them to participate, for them to benefit from this transition from a current system to the green energy system. So it doesn't mean that only decentralization is the way forward. Still, there will be centralized systems, centralized things needed, but decentralization is also need to be incentivized and needs to be pushed as a solution to this. So as I was mentioning about the UK market, again, all these challenges of centralized system means that at certain times of the day, big diesel generators and big gas plants are run to balance the system, because sometimes there is more energy, sometimes there is less energy, which means the charges are very high. So you cannot build the entire system for the peak demand. So if you're going to build the entire system based on the peak, then you're going to oversize the whole system. But then so it has to be somewhere in between, but which means that the charges, so the only 41% at the moment in the bill is on the actual energy cost. The rest of it is various charges, like government levies to manage the system, network charges. So the network charges have been increasing. So this, so all these, this is based on what time of the day you use energy. So if you use energy at certain times of the day, you're going to cost more, like 4 to 7 p.m. because everyone is using the same at the same time. So the government is putting these charges so that people can move when they use energy, which means that they do not need to increase the size of the system, but still manage the system efficiently. So this is a big challenge at the moment in the UK, and because previously it was 60% was energy cost, and there are only 40% was other charges, but this has increased only the last 4 years by so much, the other cost. Now, when we touch upon the Nigerian scenario, and from my some research and initial understanding, the Nigeria aims to raise electricity access rate from 60% to 75%, and it's especially 90% by 2030. So as you know, a lot of areas, the access to energy is not there. People do not have good quality energy. And how can that be improved? And power outages are there, and there is heavy reliance on diesel generators. On the other hand, the cost of renewables is decreasing. So getting solar panels, battery storage, all these technologies are reducing in price. So how can we make this, make use of them, and benefit everyone? I did go on a trip to Nigeria last year, and had a fantastic experience and great hospitality from the people I met, and really enjoyed the trip. And there was a workshop organized about to discuss about these kind of future energy systems and the opportunities. And met some local partners so this event was organized in Lagos. So I got to know a bit about the market. I also went and visited a university campus Covenant University, who are also generating energy on their own campus and how they are providing it. So that is an approach. So learned a lot. But there is a huge amount of learning and understanding we need. The key thing I understood is the partners. We want to see the right partners that we can work with in Nigeria, and how we can work together. So when we talk about these smart local energy systems and the concept, which I talked about, again, the objective is bring the cost of green energy low. How can we make the cost of green energy low? And for this, again, this coming from the UK scenario, the way we are doing it is, so we are setting up a central platform, and we are connecting different users to this platform. And some of them are large users, some of them are the smaller users with smart meters. And we are trying to focus on certain distribution regions, not look at everywhere, because this has to be focused on distribution regions, so that we minimize using the transmission system. So again, that will reduce the cost of moving energy from one place to another. And by doing this, what we are, and then on the other side, we access the energy markets. So we do as much of the optimization among these users, and we buy less to make sure we buy less energy from the market, especially at peak times. By doing this, what we are able to do is we can get cheaper tariffs to customers. People with renewables like solar, they get better payback. And people with battery storage or smart technology for reducing usage at certain times of the day, or all these kind of efficient technologies, they get better rewards. So which means there is a business case for it. And we also work with energy suppliers. Obviously, a lot of the energy suppliers working with the current model, there might be certain conflict of interest if they don't see the longer term vision, and they don't embrace this transition. Because the way we are doing it is we are not going to buy a lot of energy from the grid, though we are going to be transporting energy. We are reducing energy, but their model is based on selling more energy. So there is a bit of a conflict there, but then if we have certain suppliers who understand that they have to change, they have to embrace the new model, so they are willing to support the systems now. And they get a lot of benefits in terms of reduced operational cost. They can, obviously they can get more customers, they can retain more customers, feel more happy. Again, this is just a representation to explain what we call it. The system that we use is a virtual power plant system. So we are able to collect data from different assets. Also, we can send control signals to different assets. So one side you have the users. The users can be just homes with meters, or businesses with batteries, small businesses, or it can be large businesses who may have multiple buildings with solar, EV charging, battery storage, and things like that. But the key thing is we need to first get the data to do the energy trading and optimization, and then we send signals back to optimize these assets. On the other side, obviously, we have the energy market. We have the distribution companies, we need to pay their charges. And then we may also work with independent generators who may have their own solar farms or wind farms whom we can do a agreement with. So just a brief about how the system works. So it has a combination of technologies. So I'll talk about the platform level, how it works. So the first, it's more about, say, if you assume that there are a lot of sites, and then some sites will have different configuration, a lot of sites with just the demand, some sites with generation, storage, and then we are basically optimizing the shape, supply, demand. And whenever there is a gap, we are using battery storage or flexibility. Flexibility is whenever we can turn things down, turn the usage of buildings down. So we are doing that so that we minimize, so we're doing the supply demand matching and balancing. So it's like a peer-to-peer kind of optimization, and then we buy less from the wholesale market. The other, so this will deliver savings, but also we can also see if there is opportunities also to sell energy back to the system when they need it. And that is the demand side response side of things, where you can earn revenue as well. So this system is in place in UK, in US, in Australia, but I'm sure these kind of things are coming up in every country. So customers, again, this is only a sample dashboard. We have different screens for different types of customers. So the key thing is they will be able to see how the price is changing during the day and how their usage, how much are they using and how much they will use in the future. So that's the kind of we are able to show that to the customers, and customers are able to manage their usage accordingly. But if they have our smart box, which I'll come to it, our site level technology, we can automate it as well. So if they want. So this is the Qenergy platform with the smart box. So we have like a gateway. I'll show the picture in the next slide. But this is a smart box which can collect data and also send control signals. So it can collect data from meters, building controls. So when we work with buildings, for example, commercial buildings, they have central control systems, so which can control heating, ventilation, air conditioning, lighting, and things like that. So we are able to send control signals to them. First, we need to, but then when we are doing this data collection, with the data we collect, we are able to build a kind of artificial intelligence model, a data model of the building, which means we can say by turning things down or optimizing it at certain times of the day, with how much of that we can do without affecting any of the operations or the process in the building. We can also connect with other assets, as I already mentioned, like battery and EV charging, again, to do the same. So it's like one of the smart box. So this, we are buying it from the market, but we are trying to develop our own customized version of the smart box. We then install our software inside this, and this is able to talk with different systems, whether it's a Siemens systems, Philips or Honeywell, whatever systems in the building, we are able to connect to that. Or in terms of batteries, again, we can connect with different types of battery storage. So this is just a image to show one of the buildings we're working with, the battery storage that is we're connecting with. It's a Tesla system, but it's a commercial Tesla battery. Obviously, there is also a domestic Tesla battery, which is a smaller one. This is a 200 kilowatt, 400 kilowatt hour battery. So this battery can run the building for 2 hours. The building can run on it for 2 hours, so that it can avoid all the charges. Or also, if there is solar generated, obviously it can be stored and it can be reused. So this is an example how we can connect with battery storage and control it. So again, it's in terms of how a platform aggregates. So we have all the sites connected to the platform, and then we have the markets, energy markets. When the price is how we buy, we make the strategy of how we buy energy, and then we minimize the usage or maximize the usage at certain times of the day. And then, as I already mentioned, there is also the grid network. When it is constrained, they send a notification so we can release energy from the battery, or we can reduce the usage in response to the signal, which means they pay for that as well. Now, what I want to briefly talk about is this Energy Catalyst project. The one we are doing it in Nigeria. This is a program from the UK government with other governments across the world, so where they want to do this collaborative projects. So the objective of these projects, this Energy Catalyst project, is to demonstrate this kind of smart energy technologies, whether we can make it work in African market, and also how we can make these solutions affordable, and find appropriate business models to make the deployment possible in Nigeria. So as part of this, as I already mentioned, we're working with this project in Kuje near Abuja. There are 300 houses in this community, and there is a school in this community. And the school, at the moment, 80% of the school supply is met by generator. So it's a 1.1 megawatt 1 MVA generator, 1 megawatt generator, where with the remainder of 20% is coming from the grid, the utility grid. So there is a grid connection here. The utility company is AEDC. But for the homes, they do not have proper metering. They only use estimated billing. So obviously the people are not happy because they don't get enough energy most of the week. Only few hours every week they get, but they have to still pay the same amount every month. So we are looking to trial it. Obviously, we're not connecting all the houses. We are starting with 10 houses in the community, and the school, and one building of the school. How we can make this happen? How we can make the system work? So for which, what we are doing is we are putting a 40 kilowatt solar on the roof of the school, along with a battery, 60 kilowatt hour battery storage. So in the school building. And then there is, obviously, we connect the community network, which is the 10 houses in the community. We connect it. So whenever the school is generating excess energy, it will be supplied to the community. And even in the community, I'll talk about the community network in a bit, but mostly it's about the school generating energy, storing in the battery and selling it to the community, providing it to the community. And the other thing to note is, as I said, the school has a diesel generator. So certain times, if there is a need for energy, because we want to provide continuous supply to the community, that's the objective. At the end of this project, we want to have these houses with power 100% of the time, almost. So that's the objective. So whenever, but we are doing it with a small system. So the diesel generator will provide energy when there is not enough energy. So certain times the grid, we will get energy from the grid when the grid energy is available. We will get energy if the grid goes down. The diesel generator can take over for a bit, but mainly we want to do it with the solar and the battery that we are putting into the system. So the community houses, so there are, within the community houses, we want to test different models. So some of the houses will get only solar, 3 houses, 2 houses will get solar plus battery, and another 2 houses are getting just battery storage, and other houses are just buying energy. So we want to test the model, what's the benefits for different packages. So for people to use energy from this local energy scheme, for people to have a battery storage, what are the benefits? Because they can have a supply of energy all the time. At the same time, they can also give energy back into the system, or buy energy and store it in the battery. So that's the thing that we want to test, different packages and what are the benefits for each of the scenarios. And this is just an example to show about this. We're using like a hybrid inverter, which means we can store energy from solar, we can charge the battery, at the same time we can also give energy back to the grid. So that is so this is a photo from the SunGrow system, but we are working with SunGrow and another manufacturer as well. So we are having a partnership so we can provide certain battery storage technologies at very good price points. So obviously, if anyone wants to know more about the battery storage systems and the details, feel free to, you can contact us, contact me. Now, as I mentioned, there are three different scenarios which we will operate this system. So one is a grid, when the grid is down and the diesel generator is not generating, then we are mainly running from the solar and battery available in the community and the school. But when the grid is down and if there is not enough energy, we will then use from the diesel generator. When it is grid is powered, then diesel generator is not generating, we will just run with our system and independently without the diesel generator. So just to touch upon some of the regulatory side of things. So in Nigeria, the current regulation framework, as you might know, is there are from the NERC, is there are they define three kinds of systems: isolated mini grids, which is less than 100 kilowatt, and the isolated mini grids 100 kilowatt to 1 megawatt. Isolated ones are where currently the discos are not serving this area, and if they are not serving this area, then these are completely isolated mini grids. So there is no grid connection. For these, there is a way of registering, and the way of charging is specified by NERC. So for the less than 100 kilowatt, only registration is required, and 100 kilowatt to 1 megawatt, you also need to get the permit and work with the minimum network standards as described by the DISCO. And also the tariff regime, you cannot charge obviously the customers any number of any kind of charges, but it has to comply with NERC tariff regimes that they have set out. The last one is interconnected mini grids. What we are trying to do is, though we are trying to achieve this interconnected mini grid, which is where at the moment we are having our own, it's like a isolated one, but we are going to, the objective is to make it as an interconnected mini grid, whereby we are using the existing infrastructure that is available from the DISCO. Whenever the DISCO, it's within the existing DISCO's area, served area, but it is underserved. The quality of power is not there. So in those cases, we can get a permission as an interconnected mini grid from NERC and operate it, which means when we use the existing infrastructure of the DISCO, we pay a charge, appropriate charge for the DISCO to use the infrastructure. This is a good approach in the sense of you're making use of the existing infrastructure. At the same time, you are putting in the local generation, solar and battery storage and things like that, while we have our platform and the billing system to give the incentives to all the customers participating in the local scheme. I think that's about it as an overview of what our views are in terms of how we can make green energy affordable in Nigeria and also across the world. And here is my email ID, and please feel free to reach out to us. As I said, the key thing is this project we're doing in Nigeria finishes late, next year. And we are looking for a lot of, partnerships and local support to do this project. And also we are open to explore other opportunities in Nigeria. Thank you very much. Thank you.
Thank you very much, Mr. Vijay Natarajan. It's a pleasure having you on board. So for those who want to ask questions, or you have a contribution, or there is a clarification that you seek, you can use the raise hand feature. And also the chat room is presently activated. So you can put your question in there and it will be attended to. So the floor is open. If you want to have a question, please use the raise hand feature. One of the things that interests me from Mr. Vijay's presentation, which I pray becomes a reality, is the desire for Nigeria to raise electrical access rate from the present state to 90% by 2030. I think that's a good statistics, and it will be a good one for every one of us to be a part of this. And also I can remember Mr. Vijay mentioned that they are willing to partner with people. So for everyone on board, please, let's reach out to him. Let's be a part of this great venture. We have some questions in the chat box. So I don't know, Mr. Vijay, can you see those questions or you want me to read them out?
Yes, I can see the questions. Yes, I can see there's a question from Ayula. And how do you go about a hybrid system? Can it work with smart grid? Yes, it can work with the smart grid. I mean, smart grid, there are different terms to it, but essentially, if it is about exporting energy, I mean, what we consider is if we can export energy into the system and also provide services like whenever the grid needs energy, any customer can provide it from their battery or from their solar, then the grid is smart, and then obviously they get benefits for it. So this system, what we are trying to do in Nigeria is essentially to do that. So yeah. And the next one is, do you plan manufacturing the equipment in Nigeria or bring in all the equipment? No, this one, because this project is a smaller scale project, what we are trying to do is we are some of the stuff like the metering, we are working with a metering provider. So we are bringing the meters there. But in terms of solar, we are working with the local partner to get solar locally sourced. Battery, we are getting it from a global company, but they are based in Nigeria, so they have a base supply in Nigeria. But this is where it is at the moment. But in the future, we are looking for any local manufacturers and local suppliers to make partnerships. Because at the moment, we just want to test the model, and then we want to see how we can scale it. Statistical data in the presentation. Next one from Rabiu. Statistical data in the presentation, any reference? Yes, I have the references. I think I didn't put all the references in the slides, but if you want any specific ones, please email me. I can send you the reference to them. Is the idea of the project just to install in Nigeria, from Abu Sede, idea of the project just to install in Nigeria and carry out all necessary control virtually. It will be a combination. The idea is we are working with the company in Abuja called Vijay Energy. And what we are going to do is we are setting up like an operator kind of platform. We will provide it to them, and they will operate it. I mean, we want to do a lot of them virtually, but obviously there will be a lot of on-site work needed and coordination needed. That will be done by the operator of the project. So Vijay Energy is installing the assets, and then they will be operating them with the platform. So that's the idea. So we, as I said, that's where we are looking for partnerships in terms of people who can help to take the platform, take it to Nigeria. I think someone's asked to forward the presentation email, which is fine. If you can, again, email me, I can send you the details. Someone has mentioned Siemens is taking over power supply in Nigeria. Give your views on this development. I think Siemens, Schneider is also active in Nigeria. I think all the big companies are working in this space, but the way they are approaching it is more of this kind of a centralized approach. Though they are doing this isolated mini grids and captive power plants, I think more captive power plants where they install it on for behalf of a big industry or a big university campus or something like that. But what we really want is this energy transition, or energy should be like become like almost like Uber or Airbnb, where it benefits everyone, you know, not like a centralized approach. So that is where we want to specialize in. So I think the big companies, they're trying to do more of a centralized approach, though they can go into this space as well, but it is very not very cost effective for them. So they in that way we want to enable. So what we want to enable is like more of a marketplace where once people can participate and everyone can benefit from the services. Yep. See, based on Nigerian situation, how do you plan to tap the opportunities? We don't have an answer. I mean, there are different things we want to explore. I mean, this project, hopefully we will install things, and which is at the moment is in procurement stage, and we've done the detailed design. So we first need to install everything, test everything. Then there are different opportunities. One is this microgrid, interconnected microgrids. We can expand that with the DISCO. But also if you can take it to large campuses, and the universities and the industries. And the last one is we want to explore also the home battery market, where we can, if we can provide a solution to replace the diesel generators with a lithium-ion battery. I know the cost might be a factor, but then we have certain partnerships because of being involved in some big battery projects. We can get some of the costs down, so we can make it viable for the Nigerian market. So the lithium-ion batteries will have 90 to 95% efficiency, which means we don't lose the energy as we lose in the lead-acid battery. See, so what is your expectation regarding the grid cost versus the system you're deploying? Obviously, we want to say that we want to make it cheaper compared to the grid, for sure. Also, the other thing is because it is based on metering and the actual usage, I think already there will be some benefits and it will be cheaper than the grid. But overall, also we want to make it cheaper. Again, we need to still pay the distribution charges, distribution network, but we can try to bring down the cost. Because of using very cost-effective solar, battery, and everything, we can bring down the cost compared to a grid system. Yep. Forward the presentation. I'll take that email. Used from different vendors. Next question, I can see various components used from different vendors, which you mentioned. Yeah. So yeah, it is from different vendors, but again, we're not trying to do everything. We are just going to be focusing on the software and analytics and control side of things and the platform side of things. But in terms of hardware, we will work with partnerships and try to get the cost down through that. Okay, someone has asked about solar and what happens in the rainy season. First thing, I mean, as you know, the solar is not about the intensity of the sun. It's more about the sun rays being there. That's it. So even in the UK, when the sun is, sunshine is low, you can still have solar, and the payback is 8 years, 9 years payback. So it'll obviously at certain times the energy generated will be less. But obviously on a rainy day, on a gloomy day, still it'll be generating energy. But that's where the battery storage and other things also will come in if there is a gap in the energy. Another question, how sustainable is the idea of smart energy with meter of the solar panels still far away from grid parity? Also, roughly it costs 1.5 liter of fossil fuel to produce an average solar panel. I think that's a big question and a different topic, but I think again, people are working on advanced solar technologies as well, so that you can produce more from the same size of the solar. So there are lot more advancements happening in the solar as well in terms of improving their efficiency. So yeah, it will become more and more efficient in that sense. What is the type and capacity of the batteries you're using in the storage? There are different ones. The one I showed about SunGrow was like 4.8 kilowatt hour, but we also have 1.1 kilowatt system as well. And everything is lithium ion, but the detailed chemistry, obviously that can be provided as when we do the specification, the chemistry comes in that. So those are the type of batteries. There is also BYD batteries as well, which is again 2 kilowatt, 4 kilowatt systems. Another question, my main concern is affordability. So the simple conservation of energy principles, because of losses, if it costs more to put energy from the grid in the battery, then reconvert it again. Nigeria does not have different tariffs, peak, off peak, no cost incentives to go green. I think the affordability question is the key thing is this is something that we are validating. It's not like we have an answer how this will work in Nigeria, but that's what in the next few months we will be validating how it works. But even if you because of the battery systems, again going back to in terms of losses, we don't want to have losses. Obviously, we want to generate from the solar and store it mostly. Only when we need, we want to really get it from the grid and store the energy into the battery. Mostly, we want to the local energy generated to be stored in the battery, not from the grid. So that goes back to the design of the systems and things like that. Okay. Yes, I think there is another question about distributors and venture capitalists. Again, we do not have, we did not finalize the distributors in Nigeria yet. So we'll see if you can contact us, contact my email. That will be very good if you can pick up a conversation on that. How can we identify a good battery? Again, it's a big area, but there are established vendors which have tested battery systems. Again, if you can compare it with the cost across the world, what's working. We see Tesla is there in terms of more, which is well known, but it's very expensive. And then you have BYD, which is very good quality. Some battery manufacturers focus on commercial, some focus on residential. So I think you can look into that as well. And the key thing is also the inverter as well, linked with the battery. So which is like even for solar, the inverter is so important when we make a selection to what to buy. Can other forms of renewable energy incorporate into a smart energy system? I think yes, and we want to explore that as well. Other systems can be incorporated, like you mentioned, fuel cell and other things. So I think that is possible. Okay, there's another question, which is more of a general question about buildings. There's a do you have plans for south region of Nigeria? I think yes, we can look into that, and there is no restriction. We're just looking at the opportunity. If you can find a project to start with, even if it's a small project, that's what we want to do. Now we have like 1.5 years as part of this project, so we have some resources. So we want to, if we can find a small project where we can make some quick wins, then we can start to build from that. Yeah, I think that's everything. distribution network companies in Nigeria complained about staggering energy theft. Yes. So in this one, we have to factor into that. I think obviously there will be certain things that will be losses. Still, we are looking into that, whether how we can make it that we can protect the system. But again, because of the data, so we should be able to know if something happens, we should know it immediately, not like in a month's time. So if we can quickly detect from the data that is coming from the systems and the remote monitoring, through remote monitoring, we can ensure the reduced theft. And also, again, we don't want to have any deals with the disco. We may want to, we can directly with the consumers. So it's a combination we need to look at. Yes, yeah, I've got some emails. And there's a, yeah, I'll note this one. There's a request from Rabiu Haruna, and I'll note that, and I'll contact that after this call. Is that everything? Hello.
Hello. Well, yeah.
Yes,
I think that's all the question.
Yeah.
Yeah. I can't see anyone. Thank you very much, Mr. Vijay. Or is it Engineer Vijay? Because I saw Engineer Vijay in one of the questions.
Yes. Yes. Thank you. I mean, anything is fine. Honestly.
Okay. I just want to be sure.
Yeah.
Okay. Thank you very much. I think we have. So maybe we can attend to that before we proceed.
The last question, you mean? Yeah. Yeah. Do you have plans? I think it's related to other forms of energy, to bring researchers in that area, to bring other. I think we are interested. As I said, if you can send us an email, that will be very good. We can explore that. Also have someone talk about different types of batteries. 1 second. Yeah. I think that's fine. Yeah. I think that's a bit more detail. So I think I'll deal with on email if you can reach out about the battery details.
All right. Thank you very much, Engineer Vijay. We appreciate your time spent and also the wealth of knowledge which you have disseminated to every one of us. APWEN President Ma, I don't know if there is anything I need to do next.
No, there is nothing. You can just go ahead and share the feedback forms.
Okay, thank you very much, Ma. Before we go ahead, we just quickly want to get a feedback from every participant. So we appreciate if you can just quickly do that now. There's going to be a poll that's going to show on your screen now. Please just help us quickly attend to this poll and so that we can quickly do that and then go to the next step. Thank you. Okay. Upon President Mark, can I hand the button to you for the certificates and.
Okay. I would just like to appreciate you, Vijay, for this excellent presentation. And we would like to present you with this e-certificate. We're going to, you will get that in the mail after this time. It says it's our honor code certificate presented to Vijay Natarajan for an excellent presentation on affordable green energy using smart energy systems. A webinar offered by APWEN on an online learning initiative of the Association of Professional Women Engineers of Nigeria. Thank you for the presentation. We will send this to you in the mail.
Thank you. Thank you very much.
So thank you very much, Engineer Funola Ojelade, FNSC. We have Engineer C.I. Okoli raising his or her hand. Ma, can we go ahead and take that?
Okay, Engineer Okoli is the chairman of NERC Abuja. Please, we'll have you quickly because it's time for us to end the. Yes, we'll give you that honor, sir.
Thank you, Madam. I only want to pass the goodwill from myself to APWEN. You are doing a good work, and we want you to continue. Thank you very much, and have a nice day.
Thank you so much, sir, Engineer C.I. Okoli. I think we've come to the end of today's presentation. I want to appreciate everyone for coming. Next week is another time. We'll let you know as this proceeds. Not for your support, we will not be able to continue this. I want to thank everyone who has supported us in so many ways, particularly those who have requested for our certificates. Like you know, we use the proceeds we get there just to support this platform so that we can continue to offer this for free. Thank you once again, and God bless you. Have a wonderful weekend. Thank you, Vijay.
Thank you.
Thank you very much, everyone. The video, the presentation will be sent to your emails that you provided before joining the meeting. Thank you.